I wanted to provide a little more instruction on how to accomplish Project Helium. So Project Helium, we are looking at a demonstration where we're deciding if things are electrolytes or not. There are several substances tested, and so what I would like you to do for these substances tested, and for each one of these substances that have been tested in the video, I would like you to tell me, are they an electrolyte or not? Okay, and provide some details as to why they behave as an electrolyte or they're not an electrolyte. I also want you to draw a model. And this doesn't have to be fancy. I'm not grading you on your artistic skills. I'm just trying to see whether or not you understand how things are behaving on the molecular level. And I will show you an example on the next slide of what I'm looking for. Okay, so we're going to draw a model, and then if it is an electrolyte, but only if it's an electrolyte, include a dissociation reaction. Okay? And so that's what I'm looking for each one of these substances. There is also a substance, and for tap water, I would like you to use calcium chloride as the dissolved substances in tap water. There's lots of different compounds that are dissolved in tap water. However, for simplicity's sake, you can just use the calcium chloride for the model, and then also if you need a dissociation reaction, use the calcium chloride for the dissociation reaction. Okay, I'd also like you to predict for Gatorade if it will be an electrolyte or not. So you can look up the ingredients and make sure you cite your source. So wherever you find the information about the ingredients, okay, include that in the slide. Draw a model based on those ingredients, and if you need a dissociation reaction, write the dissociation reaction based on the ingredients that you find. Okay. All right, so I'm going to go through an example. This isn't one of the substances tested, but this would be an example of how you would go through and decide if it's an electrolyte, how we're going to draw a model, and what the dissociation reaction would be. So here's an example of sodium sulfates. We're going to decide whether or not it is an electrolyte. So in order to be an electrolyte, it has to be able to break into individual ions. It has to be an ionic compound that is soluble. So we know that it's an ionic compound because we have sodium metal attached to a polyatomic sulfate anion. So sulfate is covalently bonded together. The S and the oxygen, the sulfur and the oxygen, are sharing electrons, but as one unit, the whole thing has a charge. So we know it's ionic. We have to see if it is soluble. So it contains sodium, which is a group 1A ion. So sodium is soluble. And no matter what it's attached to, there are no exceptions. But if we want to check sulfate, sulfate's usually soluble. Okay, sodium is not one of the exceptions, so that does not contradict our first rule of it containing sodium. So we do know that this is an electrolyte. Okay, we know that it is going to conduct electricity because there are ions present in the solution. So we know it's an electrolyte. That means that we are going to have to write a dissociation reaction, and it can be helpful to do that before we draw the model. So for our dissociation reaction, we always start with the compound as a solid. No parentheses are needed because we only have one sulfate. it's going to break into the ions. So this 2 subscript tells me that we have 2 sodiums that are going to dissociate away from each other in the solution. And we put an AQ to represent that it is dissolved in water. So we don't need to include water in our reaction because that AQ tells us that it is water. Okay, now the sulfate we said is covalently bonded to itself, and so the sulfate has going to stay together as one unit, and it is going to be aqueous, so it's one polyatomic unit, stays bound together in the solution. So this would be our dissociation reaction. We want to make sure it's balanced. So sodium, there's 2 sodiums. We have 2 sodiums on the left side and on the right side. We have 1 sulfate on the left side and 1 on the right side. Now for our model, now they don't have to be fancy. I'm not grading you on your artistic ability. I just want to see if you understand what's happening on the molecular level. So for this one, I'm going to want to make sure that I have things in the proper ratio. So I'm going to want 2 sodium ions. And we're just going to use circles for sodium. I'm going to need 1 sulfate. And there's going to be more than one, right? So we just need to make sure that they're in that ratio, 2 to 1. And so I'm just going to draw a box. I'm going to label it as sulfate. Okay, now I want to make sure that I represent my water, in this case that's dissolving my sodium sulfate. So water is a polar molecule, which means that there is a side that's more positive and a side that's more negative. So the more negative side is the side that contains oxygen. And because sodium is a positive ion, that more negative side is going to orient itself towards that positive sodium. So for both ions, we're going to have our oxygen towards the sodium. I'm just going to draw a little key here so that I know that you understand what's going on. So 2 hydrogens, my 1 oxygen. Now, for the sulfate, because it's negatively charged, the positive hydrogens are going to orient themselves towards that negatively charged sulfate. And we have lots more water molecules than we do the ions in the solution. I'm just going to draw a handful to get the idea across. And again, this doesn't have to be a fancy model. I'm just looking to make sure that you understand what's going on. Does it stay together as one molecule? Does it break apart into ions? How is it behaving on the molecular level to make it an electrolyte or a non-electrolyte? Okay. So hopefully this clears up a few of the questions that you have, and let me know if you do have any additional questions. Thank you.